Walls, fences, roads, and highways. All of these make life easier for people, but they can devastate the life cycles of the animals that must get past them to survive. Can scientists find a compromise? And the richness of our world wide open spaces. Finding, capturing, and preserving those spaces not with your eyes, but with your ears. Researchers call it acoustic ecology.
That's coming up next on Catalyst.
This YouTube edition of Catalyst is brought to you by Arizona PBS and Arizona State University. Life has problems. Science turns them into questions that can lead to solutions and even innovations. This is Catalyst, shaping the future through science research at Arizona State University.
Many mammals need to cover a lot of territory just to stay alive. Now that's true for most big cats in the wild, like cheetahs. They need a lot of space, not just to hunt enough food, but to make sure their choice of mates leads to healthy offspring. Here at the zoo, these animals are kept safe in their enclosures by smart designs built into the landscape. Out in the real world, however, we humans keep making things harder for many animals that need lots of space to survive and thrive.
You can put camera here. The jaguar appears here 2 or 3 times.
Carlos Robles is helping biologists set up dozens of new camera traps around his property. He wants to see how wild animals are migrating through his cattle ranch in Sonora, Mexico.
I've seen the biggest lion in my life here. Not with my eyes, with the camera.
Yeah.
His sons, Carlos Jr. and Germán, help manage the cattle business but are increasingly worried that the biodiversity they grew up with is under threat.
This is called El Río Cóspera. Estamos en un área muy importante llamada las Sky Islands. Si podemos ver el mapa en las Sky Islands, que incluye Sonora, Chihuahua, Nuevo México y Arizona, estamos nosotros como en un reloj de arena. Hay un ecosistema muy grande arriba y se va cerrando y se hace un cuello y hay otro ecosistema abajo. Entonces, esta área está ubicada en la parte más delgada de esa figura de ecosistemas.
From here and south, this is a wetland that we're trying to exclude from grazing. We don't want any grazing animals here, except for wildlife, such as whitetails and other animals that live here. De mis primeras experiencias aquí fue cuando mi papá me enseñaba a ver aves con los binoculares, ir a buscar venados, empezar a encontrar huellas, identificar esas huellas. ¿Qué animales viven aquí? ¿Quién está aquí? ¿Qué hacen?
The wildlife, the biodiversity in general in this area is just outstanding. And it's really cool because in this area of Sonora, Mexico is one of the main corridors for jaguars in Arizona, which doesn't happen often, but it's awesome that some species from Mexico can come up to Arizona.
Entonces son lugares muy importantes donde hay agua, donde convergen algunos hábitats, como el hábitat ripario que conocimos hoy, como el desierto alto, pastizal chihuahuense, etc. Porque aquí se juntan muchos ecosistemas y se forman ecotonos, que son muy importantes.
They've invited biologists from Arizona to measure animal migration patterns before and after a new highway is built through their property.
We're setting up 6 transects along the highway, and it's going to be 24 cameras total. And then that will give us some sort of baseline to compare to after the highway is actually built, to see how the ecosystem changes, how the wildlife changes. Definitely some of the biggest challenges is not necessarily knowing the terrain beforehand. What we've been using is satellite imagery and just the ranch owner's personal knowledge.
Personally, I really like working with the private landowners because they have an invested interest in it with us, and they're always so eager to share what their story and connection is with the land. It's always neat when we're out in the field not to just look only at a good place to set the camera. We kind of look around and see what kind of trees are there, what kind of insects are there. We're all very hands-on and wanting to know as much as we can about something, how it feels, how it smells. Today when we were walking, we found several different types of frogs, and we carry little identification guides with us. There's one frog that the Phoenix Zoo works highly with, is the Chiricahua leopard frog, and so we always like to see where they might be. Today we found a lowland leopard frog. Pretty neat find. Everything in the desert is limited by water. So with us putting cameras along these riparian areas, we're trying to see the animals that are following water and how they're going to be able to continue their migration that way.
So we're going to set up a camera trap right along this tree here, and it's going to go along the log crossing the river. What we want to capture here is any species that may use the log to cross, such as coati, and also any species that will just walk right past the log. So you can get deer, you can get skunk, etc., maybe even puma. It's right by the river, so a lot of species will want to catch a drink from there. Oftentimes puma or other species of cat will not want to cross the water, they want to get their feet wet, so they'll use these log crossings to cross. So this gives us a higher chance of capturing these more charismatic species. The most rare is jaguar, and a lot of jaguar will come up from Mexico, Sonora, Mexico in particular, into even Arizona. So that is one of the biggest things we're looking for, are these corridor pathways for these larger mammals coming up from Mexico and Arizona.
Yo siempre cuento esta historia porque yo estaba platicando con un amigo de infancia, le platiqué que aquí habíamos encontrado jaguar, porque ya lo habíamos fotografiado, y me dice que yo estaba loco porque el jaguar no existe en Sonora, el jaguar es de África, según él. Eso es interesante porque la gente no sabe lo que tenemos y es importante. Y habiendo proyectos como estos, es como la gente se entera, aprende más sobre lo que tiene y cuando aprendes es cuando valoras algo, pues.
Most stuff that we use it for is statistical stuff, so analyzing how many times we capture them, where we're capturing them, so that can give you an idea of how they travel, how many there are in the area, how the population is doing, etc.
Ooh,
Bobcat.
Nice, that's awesome.
I like the night scenes.
Coati. Coati butt.
Nice. So we got one cat, which is pretty cool. Yeah.
One bobcat.
A lot of coatis. Got some coyotes.
A lot of whitetail.
Yeah. A lot of javelina too. So definitely a well-used area.
Yeah. If we set up the full grid system that we want to, that'll be 24 cameras. I think the most rewarding part is feeling like you're doing something to contribute as far as wildlife. For this would be using this data before the highway's even built. Once it's collected, we'll be able to offer some sort of input to like the Mexican government when they're building this highway, of saying like this type of species would really benefit from an overpass here, or this type of species is high abundance here, maybe have an underpass on the highway.
When human construction projects slice through animal habitats, they isolate species and prevent them from reproducing. It is especially problematic for endangered species like jaguars and ocelots.
And a few of the ocelots have been spotted in the United States. We think that maybe this is a breeding point for many of those ocelots that have been sighted. The US border is just 30 miles away from here in a straight line. In a few places it will be a fence just like this, where wildlife can still go migrate to the north and south. A border wall will be very damaging for the environment, because many species won't be able to go across as they should.
If we want to maintain the integrity of these landscapes, if we want to maintain healthy populations of certain animals, we need to provide everything they need, and we might not have it in any one side of the border.
A group called the Wildlands Network helps landowners in the Sonoran Desert keep wildlife habitats connected.
The kind of work I do involves mostly protecting connectivity for wildlife to be able to move from one place to another, particularly in the borderlands of Mexico and the United States. An instrumental player in this is, of course, the Robles family. They are the owners of the property. They got it certified as a private protected area, but they need support from lots of people, from specialists who can conduct science there, people who can coordinate philanthropic efforts that can bring resources to Rancho Laribabi, and advocates like us that can collaborate with transportation authorities so that the road near Laribabi has fewer impacts.
Further north in Arizona, state agencies are mapping habitat fragmentation and designing structures to help animals navigate around human traffic.
And this particular overpass is set up to connect wildlife between the Tortolina Mountains and the Catalina Mountains. So animals that want to travel from point A to point B can get across the road safely for migration, for water, for food, for mating, anything else that they need to do. So having connectivity like this is extremely important. A lot of the wildlife crossings that go in Arizona and other states are mainly safety driven. When vehicles are driving down the road, they hit a deer or an elk or any sort of wildlife, and it can cause damage to the vehicle, and it can also cause fatalities to motorists in some instances. The roads are almost a complete barrier, especially the larger roads, highways and interstates. And you'll see those animals will come up to the road, they won't cross the road, and they basically live, their entire home range is within areas on one side of a road or confined by the roadways. And so animals need to be able to make these long-range movements to be able to survive. This particular overpass has had over 3,000 deer use this structure. Here's an example of some of the still cameras which collect photos for us as these animals use the structures. Another way that we collect wildlife use is we use a video camera system. And so down here you can see there's photo beams. When those photo beams break, then you basically start recording with these cameras that are up above us. And those cameras allow us to look at the animal's behavior to see how they're reacting to their surroundings and traffic passing by, and just to see how nervous they are or comfortable they are using the structures. So this is the underpass along State Route 77 that's nearby the overpass. We wanted to provide different opportunities for different wildlife species. And a lot of different wildlife like the underpass, like the javelina and the bobcat. They'll use this regularly. Got things like coyote tracks, and here's some more right here. A whole bunch of different wildlife use the underpass, and there's several cameras that allow us to see how many animals come up to the underpass, how many go through, how often they go through. And it gives us a good comparison to the overpass, as well as lets us combine the data from the two to see how well the whole suite of structures is working to help get wildlife from the Tortolita to the Catalina Mountains. There's a couple reasons why these animals learn to use these structures. Probably the key thing is the exclusionary fencing. There's fencing along this road for big and small animals alike, which when they get to the road, they can follow the fencing until they get to that crossing. Once they learn that crossing, then they'll start to cross there. And what we see over time is those animals start to use them more and more, and you'll actually see the increase in use, almost like a learning curve. And then you'll start to see the moms bring their young, and you'll start to see the young cross, and then over time it just starts to build and build and build, and then it becomes their primary corridor from that point on. There needs to be a way for humans to be able to coexist with wildlife, and the way to do that are things like wildlife crossings and corridors. It allows you to build communities and leave opportunities for wildlife to live and move and be in those areas with humans. If we don't take care of the wildlife, then they won't be there for our future generations.
The Robles family is optimistic that camera traps will show people a new outlook on wildlife protection.
Lo más importante es porque que se crea ciencia aquí, que sepamos que tenemos que proteger nuestro desierto y no dejemos de hacerlo nunca porque es muy frágil.
They also suggest taking a walk in the wild to see nature's beauty for yourself.
Many people come to a beautiful setting like this one at the Desert Botanical Garden to look around and take lots of pictures. But what many of us don't do in a natural setting is actually take a minute and stop. Stop looking, stop clicking. Just be quiet and listen.
Listening is actually a very sophisticated skill. It's a form of communication. It's an active process.
How you doing? Good, thank you.
Many people just don't listen to plays when the voices of plays can be so powerful. They don't even bother to understand their sonic environment, which could be so rich and rewarding.
I thought that it would be cool to do something with these hydrophonic recordings that could also be introduced to the field recording database.
Sabina Feist is a very good listener. She teaches history at ASU's School of Music, but her perspective on sound is unusually scientific.
You could actually do a sound map even, once you have the map. And I have become very interested in music and the environment. This is a field that's now called ecomusicology.
Many of her students are part of the Acoustic Ecology Lab, a group of scientists and musicians who create and study recordings of wilderness environments.
So we need to go out and change the batteries in the SD cards on a 2-week basis. so that we can get a steady flow of data over a certain time period, which has been now almost a year.
They are trying to hear nature on a deeper level.
But for right now, what we need to do as a lab is go through these recordings, listen to all of them, and tag the events that we hear.
We want to understand the totality of our sonic environment, how human-generated sounds interact with animal sounds, with the sound of wind, water, and how human-generated sound can perhaps have an unfavorable effect.
Sabina Feist's co-director at the Acoustic Ecology Lab is musician Garth Payne. He also teaches at the School of Music and helps develop tools and techniques to capture field recordings.
And it's running some code that's allowing us to record off this little digital MEMS microphone, and we're basically recording 24 hours a day. Listening to the environment tells you a great deal about the ecology that's present in that place in a way that taking a picture or a video just doesn't. If you go and you actually sit down and you just sit still for like half an hour and you try to put your listening out into the world around you, you'll discover that it's actually full of tiny little critters of all kinds, right?
I was a musician throughout most of my life. It wasn't until I got involved in the Acoustic Ecology Lab that I got involved in environmentalism, and this sort of sparked that drive for me, and seeing the work that Dr. Payne was doing in sound and the science behind sound and how it correlated with environmentalism really interested me.
Kyle Heyfur helps research noise pollution near a local wildlife preserve. He places microphones across the park so that ecologists can hear changes in animal sounds and migration patterns. He hopes the research will help city planners protect the environment.
All right, so here's our audio unit, which we use to record the sound here in the McDowell's Preserve. What you're looking at on the front is actually 2 microphones, a stereo pair, through a couple of straws, and this helps protect all of the components inside. So when we open up the back, first thing you're going to see is a LiPo battery, and this battery powers the unit for about 4 or 5 days of continuous recording. As we go further into the unit, nestled inside is a Raspberry Pi microcontroller with a audio card on the front. And so this is where you can see the 2 microphones. They're very, very tiny. So these systems are changed every 2 weeks. So we have about 4 or 5 days of continuous recording every 2 weeks for about 11 months now. And what we are listening for specifically is sort of the general loudness of the area, the general sharpness, these psychoacoustic measurements that might affect wildlife in these areas. This microphone specifically is right next to a highway. So it picks up a lot of the low rumbling noise that we attribute to animals perhaps not coming to these areas. Well, in the desert, because we don't have a lot of large plants and a lot of foliage to block sound out here, sounds can travel extremely far. And so when we look at developments in these areas, we need to think about this sort of aspect of sound and how it affects the animals and the species that live there. Because of how hot and dry it is, we lose a lot of the high frequency sounds when it becomes less humid. So as we need to think about this constant rumbling from cars and from planes, and we need to think about how certain species of animals communicate via sound, and they might rely on the lower frequencies of hearing or the higher frequencies of hearing.
And so you can see here bits of kind of noise up to about 1.5 K. But if we look here, you can really see these bird calls very clearly here, and actually a different bird here. You can hear this, and then this little like, just hear it in the background there. But that's getting masked a little bit by this always low frequency, and that's very consistent. So it could...
A big way to address this issue would be planning. And we can see this specifically in the preserve with this roadway that's cutting through the middle of the preserve. It's a 2-lane highway. and there's a lot of traffic because there's a lot of folks who live out there. But we're having issues with certain species of deer not crossing the roadway. We can't tell you if it's due to sound yet, that's what we're starting to study, but in terms of the activity that happens there, it could be stopping the species from crossing the road, and this can cause long-term issues. Now the city of Scottsdale is planning on turning that roadway into a 4-lane road. Maybe we can think about ways that we can help the animals as well. So maybe creating an overpass or an underpass for animals to cross safely, things of that nature that need to happen in the planning stages.
Listening is a powerful tool to understand the environment in deeper ways, and we want to share our listening skills with communities to give them agency to talk about what's happening to their sonic environment and environment at large.
As part of their community outreach, the Acoustic Ecology Lab holds public workshops.
And in those workshops I teach 3 listening skills. So the first is passive listening, which is to sit there and listen to the entire world around you simultaneously, not to place your attention on anything, but just hear the entire gestalt of the world around you. And actually it's really difficult because our biology, our kind of genetic history teaches us to listen constantly for change. So it's actually quite difficult to do that, to really just let go of listening to particular objects. The next one is directed listening, where you would pick a particular sound and then really focus on that sound. So like you might be listening to a bird call and you would really focus in on the kind of brittleness of the sharp edge of the sound and really listen to every micro detail that's in there. And it's amazing how you can keep going deeper and deeper and deeper into hearing the detail in a sound. And then the third technique that we teach is what's called active listening. And so this is to listen, for instance, to that bird call and that response over there, and to really start to listen to what the interrelationships are in the environment. And when you get to that point, you're really listening to the whole ecology that's kind of vibrating and sounding around you. And then, of course, I encourage people to go out and sit down for, 3 minutes a day, 30 minutes a day if you've got time, and just practice listening, because your acuity really improves with practice. A good example is we've been doing a lot of workshops and recording in Joshua Tree National Park. And so we also take students there, and we always camp because it's a rich experience to be out there and listen to the night soundscape as well. And we were sitting at dinner and one of the students said, "Oh, it's amazing, like there's absolutely no sound out here. It's so quiet." And I said to him, "Well, yeah, except for the coyote call over there and the bird that's over there and the plane in the distance up there." And he was like, "Oh my God, like I hadn't heard any of those things."
In another effort to share their work with the world, the Acoustic Ecology Lab has created a free, searchable online database of their field recordings.
We go through and tag by hand the sound events that are occurring in these sound recordings. And then we use descriptors such as sharp, loud, dull, soft. So people can go and look up how often these events happen in the recordings that we collect from these areas where many people don't go oftentimes.
This database could help scientists in their environmental monitoring projects, and that could also be a source for artists.
Garth Payne happens to be one of those artists. His creative process involves mixing his own musical notes with nature's melodies.
I took crickets that I recorded here in Arizona and frogs that I recorded in Australia, and then I wrote a flute piece, and what happens is that as I play the flute, those things get crossed over in the software so that you end up with flute frogs, if you like, or frog flutes. So you kind of, in a sense, give a new voice to the recordings from the environment, and it becomes a performance piece. All sound is energy, essentially. And so really for me, composition is about balancing these energies to get textures that evolve and things that flow out of that or sink down through that, and to take the listener on a journey through that kind of experience.
He has also been experimenting with using virtual reality to bring a variety of acoustic ecology experiences to more people.
He paired 3D audio with 360-degree photography and mounted that together, put it in these headsets. So in that way, these nature sojourns could become portable, and we thought, wow, with virtual reality, we can democratize access to pristine nature.
And so I've been trying to work out ways to make creative works that kind of place people really consciously in the ecosystem as a way for them to consider the fact that they're always within an ecosystem and that we are nature, and that our relationship and our behaviour and our interrelationships with everything else are really important, and that we perhaps should be paying more attention to that.
I'm Professor Vanessa Ruiz. Thank you for watching Catalyst, our show about science. And because science always has new questions to answer, we'll be back soon with more stories.
Catalyst is supported by Knowledge Enterprise Development at Arizona State University, advancing entrepreneurship, innovation, discovery, and knowledge for the public good.
Subscribe to this channel to see more episodes of Catalyst on YouTube.